Hello everyone, I hope you're doing well. So in this video, we're going to discuss the problems of Codeforces Round 859, which was rated for Division 4. And in this video, we're going to discuss all of the problems. So let us quickly start with the first problem, that is plus or minus. So this problem is fairly simple. It says that we have been given three integers a, b and c, and exactly one of the conditions is satisfied with those three integers. If a plus b is equals to c, then we have to print plus, otherwise we have to print minus if a minus b is equals to c, right? And exactly one of those conditions is satisfied, so we just need to check for one of the conditions and the other one will always be true. So let me just directly show you the code. There is nothing like about understanding this particular problem. So as you can see, I've taken three integers a, b and c, and I just check if a plus b is equals to c, then I just print plus, otherwise I print minus. So this would be the solution for the first problem. Now let us quickly move on to the second problem. So the second problem is grab the candies. So this particular problem, it says that there are two people who are playing with the bags of candies, and basically we have been given a value n, and there are some integers that has been given to us, and these are basically bags of candies, right? So like whenever a bag has even number of candies, the first player grabs the bag, or Mihai grabs the bag, otherwise Bianca grabs the bag, right? So whenever it is even, Mihai grabs it, otherwise Bianca grabs it. Now once a bag is grabbed, the number of candies in it gets added to the total number of candies that the player took, right? So if Mihai grabs a bag, that it will be added to Mihai's total number of candies. Now since this Mihai wants to show off, see, he wants to reorder the array such that at any moment except the start, Mihai always has strictly more candies than Bianca. So basically, we have been given some integers, and like the even integers can be taken by player 1, the odd integers can be taken by player 2. We have to find out whether there exists an order such that the player 1 always has more number of candies. So the most obvious order would be to place the even numbers at the beginning and place the odd numbers at the end, right? So in this case, the player 1 will take all the candies first, and player 2 will take all the candies later on. But still, if the number of candies taken by player 1 is less than player 2, that means there is no such order possible. So let me just explain you a little bit of this particular question. So if player 1 can take even candies and player 2 can take odd candies, then I'll place all the even candies before. So even. So that this player 1 takes all the candies and then place all the add candies after it. So even after taking all these candies, the sum is less than this particular candies. That means player 1 can never have strictly more candies than player 2, right? So that means if the sum of all the numbers that are even is less than sum of all the numbers that are odd, that means our answer cannot exist in this particular case. Now let me just show you the code for this particular problem. It says that I have taken an integer n and I have two integers x and y. Both of them are initialized to 0. So x basically denotes player 1 and y basically denotes player 2. So I traverse through the n integers, I take them as input, and I just check if the integer is odd, then I add it to y, that is the second player, otherwise I add it to x. Now if x is greater than y, that means the sum of the even numbers is strictly greater than the sum of odd numbers. That means my answer can exist, otherwise my answer cannot exist, right? So in this case I print yes and no respectively. So this would be the solution for the second problem. Now let us move on to the third problem, that is find and replace. Now this particular problem says that we have been given a string s consisting of lowercase Latin letters, and in one operation we can take the character and replace all the occurrences of this character with 0, or replace all the occurrences of that particular character with 1. Now we have to find out whether there exists such a string such that it is alternating string. That means it has to be either 010101 or 101010, right? So let me just we just have to print yes or no in this particular case. Now let me just explain you how this particular problem works. So if I have been given some characters a b a c, right? The characters would be something like this. So like you would observe that if I want to replace this particular character with 0, then I will have to replace all the occurrences of that character with 0, or if I replace it with 1, then I'll have to replace all the occurrences with 1. Now this basically means that if I select one character, then all the positions that are at the same parity. So for example, This was index 1 or index 0, let us take. This is index 2, this is index 4, right? All those indexes of the same parity will have the same character, right? And the opposite parity should definitely have the opposite character, right? But let's say somewhere A exists like this at position, this is 6 and this is 7. So if A exists at position 7, that means this will also have to be 0. Now if at a odd position, initially A was present at even positions only, right? Now if A is present also at an odd position, then it will spoil the alternating binary string, because at even positions we had 0. Now at one of the odd positions we again have a 0, right? So if A was at even positions, then all the occurrences of A should be at even positions only. But or if A was at odd positions, then all the occurrences of A should also be in odd positions only. But if we have a case when one of the positions is in even and some other positions of or A is in odd position, that means our answer cannot exist and we will have to print no in that particular case. So I've explained you why this does not work. If you take 0 or even if you take 1, for example, if you would have taken 1 here, if you take 1 here, then again all the even positions will have to be 1, right? So all the even positions will have to be 1. So this has to be 1. This has to be 1. This will become 0. This will become 0. This will become 1. Again, now all the even positions is 1, but this position has to be 0 now. But since it is also A, so this also becomes 1. So it is violating our rule. So the only thing that we need to check is that all the occurrences of any character, whether it is A, B, C or D or any other character up to Z, all of the characters should appear at the same parity, or all the characters, like if I'm talking about A, all the occurrences of A should either be at odd positions or all the occurrences of A should be at even positions. Similarly for all the characters B, C, D and E, right? Any character should only occur at a single type of position. So let me just show you the code for this particular problem. What I've done is I've initialized a vector v of size 26 and I've initialized all the values with -1. So -1 means I've not encountered this particular string, this particular character yet. I just take the string as input, and for all the values, I just check if I have not encountered this particular string yet. I just set its position, right? I and 1 means this will be either 0 or 1 depending upon the value of I, right? So I just otherwise if I have already set it, I just check whether the position that I have already saved matches the current position of the character or not, right? If it does not match, that means I can just print no and return from directly from here, right? If all the positions match, I can print yes as my answer. So this will be the solution for the third problem. Now let us move on to the fourth problem of today's contest, that is odd queries. So this particular problem says that we have been given an array of integers of size n, and we have q queries of the following form. So in each query it will be having L, R and K. It will be having 3 integers, right? So after we perform this particular query L, R and K, we have to like tell whether the sum of the entire array will be odd or not, right? And each of the queries are independent of each other, so it will not affect any other query, right? So this line is very important, otherwise the question will become a different question and so on. So what happens in this particular question is, let me just explain you with some test cases. So because this for this particular question, I will need to explain you with the test case. So as you can see, the first two integers are n and q. So n is the number of size of the array and q is the number of queries. So the elements are 2, 2, 1, 3, 2. Right, now it says that we can replace the elements at position 2 from 2 to 3 by 3. So it will be like this. So these two elements will be replaced by 3. Now the total sum is 2 plus 3 plus 3 plus 3 plus 2. So this is 9, 10, 11, 12, 13. So the total sum will be 13 and this is all. So the answer will be yes. So if I show you, the answer is yes for the first test case. And let me just take this particular example, that is the fourth test case. So 1, 2, 3, fourth query. So if I replace the elements 1 to 4 by 9, so all of these will be 9. These will be 9, 1 to 4, it becomes 9. So 9 into 4 is 36 plus 2 is 38. So it is an even number. That is why the answer of this particular query is no. Right. So how can we solve this particular question? This question can be easily solved using prefix sums. Now, how do we use prefix sum in this particular question? So if I have 2, 2, 1, 3, 2, I can easily calculate prefix sums. Now, before calculating prefix sums, let us understand what is the use of prefix sums here. So if I am talking about any range, right, if I am talking about this range and I want to replace all the elements of this particular range by some element k, right? So how do I calculate the final sum? If I know the initial sum, let me just take the initial sum, and I know the sum of this particular range minus sum of range, and I just add size into k, So the size is the size of this particular range, and I just add it to my answer. So this would be my final sum, right? How? So the initial sum was the sum of this whole array. Now I subtracted the sum of this particular range from the array, from the initial sum. Now I added the size of this particular array multiplied by k. So because this would be k 3 times, so I just add size into k, right? So this would be my final sum, and I can easily check whether this final sum is even or not. So how do we use prefix sums, and for what we use prefix sums? We use prefix sums to calculate this particular sum of range, right? So if I have calculated prefix sums already, if I have a range L to R, I can calculate the sum of the range as prefix of R minus prefix of L minus 1, right? I can calculate the sum of this particular range in this particular manner. So let me just show you the code for this particular question now. So what I have done is I'll just taken n and q as the input, and I just go through all the values. Now for each values, I initialize the sum with 0 and I calculate the total sum, right? Again, I initialize a prefix vector and I just like set the values of prefix vector. If that is, you must already know this. How do we calculate the prefix sums, right? So prefix of I is equal to prefix of I minus 1 plus v of I minus 1. So the only reason I'm doing I minus 1 with v here is because the vector v was initially in 0 based indexing and my prefix array is 1 based indexing, right? Otherwise it would be v of I here, right? So for each query, I just take three integers a, b and c. So a and b denotes the left and the right range respectively. I just calculate the size of the range, that is p minus a plus 1, and I just here only I multiplied by c. So this size vector, the size variable now stores the total sum of the new range, that the range will be replaced by c. So this size variable here now stores the total sum of the new range, right? So I just take my sum. So this sum is the initial sum minus prefix of b minus prefix of a minus 1. As I have discussed, this is the right range, this is the left range, plus size. Since size stores the sum of the range, new range here, I just add it directly, and I do check whether it is odd or even. If it is odd, I print yes, otherwise I print no. So this would be the solution for the fourth problem. Now let us move on to the fifth problem. So this particular problem is an interactive problem. So if you have not solved any interactive problem before, you would find this problem very interesting. So in this particular case, what happens generally is you ask some queries to the judge, and the judge, online judge, replies to you with some responses, and on the basis of those responses, you have to find the right answer. So in this particular problem, what happens is there are like n piles, and each pile has some number of stones in it, right? So I don't remember. So they are stones only. So each stone weighs 1 grams except for one special stone, that is the part of an unknown pile, right? So for example, if you see here, there are 5 piles, and the number of stones in the first pile is 1, the number of stones in the second pile is 2, third pile is 3, fourth pile is 4, and the fifth pile is 5. As you can see, all of them are marked with 1, but there is one special stone in pile 2 that is marked with 2, right? So we have been given in the input the number of stones in each and every pile, and the queries will be of the form like I'll show you directly. So the queries will be of this particular form where we have to ask the judge with a question mark and then send k. So k means we want to ask a question for k piles. Now if we do this, p1, p2, p3 will be the piles id or the piles index, and the judge will return with the sum of the weights of all the piles, right? So for example, in this particular case, let me just copy this thing. So you can ask queries in the form of, you have to print question mark and then you can write some number. Like for example, there are 4 elements that you want to include and you write 1 2 3 4. So the judge will return the sum of all the stones or the sum of weight of all the stones in these 4 piles, 1 2 3 and 4. So in this case 4 5 6 7 8 9 10 11. So the judge will return you 11. So if you see, the first pile has 1, the second pile has total weight 3 because there is one stone with a special weight 2, and the third pile has total weight 3 and the fourth pile has total weight 4. So 4 5 6 7 8 9 10 11. So the total sum would be 11. So you can ask queries of this particular type, right? Now we have to find the pile with the special stone, right? This is our question. Now again, there is one very important constraint that we can ask at most 30 queries. So how do we solve this? Usually when you will find these types of questions, these questions are generally of binary search. So most of the times these types of questions will be easily solved with binary search. And this particular question, as I've discussed, is definitely a binary search question. So let us discuss how can we solve this particular question with binary search. Now, let us assume that initially we assume that all the piles have only stones of 1 weight, right? So the first pile should have weight 1, the second pile should have weight 2, 3, 4 and 5 respectively, right? This would be like this. Now, let me calculate the prefix sums for this particular thing. So this would be 1, this would be 3, 6, 10 and 15. Why I calculated the prefix sum? I just needed some values for the range, that is why I calculated the prefix sum. So if I talk about this particular range, let's say this particular range, right? So this is, let's say, my lower end, this is my higher end and this is my mid, right? So if I talk about mid to high, what would you say, what is the expected sum of this particular range? I would say it is 15 minus 3, that is 12, right? Even if I check from this thing here, 5 plus 4 is 9, 9 plus 3 is 12, right? So in both of the ways I calculated the answer to be 12. So in this particular case I just did 15 minus 3 to calculate the sum of this particular range. So 12 is my expected range, right? 12 is my expected value if all the stones in this particular range have 1 weight, right? Now I ask my judge this particular query. My query is, so I ask my judge. So I ask my judge this particular query. I print a question mark. I say I have 3 values. I want the answer for 3, 4 and 5. Right. So the judge will return me 12. Right. That means that all the values in this particular range have the expected value. That definitely means my answer does not exist in this particular range. So let us say we move on to the left range. So if my answer does not exist in this range, I move on to the left range. So let's say I move on to this particular range. Now this is my mid, this is my high, right? So let us again calculate from mid to high, right? So if I calculate from mid to high, again the expected sum of this range is 6 minus 1, that is 5, and even if I calculate from here, 3 plus 2 is 5. So 5 is the expected sum. But if I ask my judge this particular question that I want to calculate for 2 values, that is pile number 2 and pile number 3, the judge will return me an answer 6. So this particular answer is greater than my expected answer, right? That means the answer must lie, that the pile that has that particular stone with value 2 must lie in this particular range only. So I discard my left range and I am left with these 2 values, low and high. So if I have only 2 values at the end, I can just check for them independently. Like one of those would have the the value greater than the expected value, right? So the basic idea is, take any range. For example, if you have this particular whole array, right? You start with the initial range like this. You take any half of it. Either you can take the left half or you can take the right half, right? So let us take the left half for now. So I just check in the left half whether my expected sum is equals to the actual sum or not. So if the actual sum that my judge provides me is greater than the expected sum, that means the pile with the store which has an extra weight 2 is definitely present in this particular range. Otherwise, if the actual value is equals to the expected value, that means I have to search in the right range, right? So when I get to the right range, again I initialize my mid value, again I check the left range. Again, if the actual value is greater than expected value, that means in this particular range my answer exists, otherwise my answer exists in the right range. So this is how we have to use binary search in this particular problem. So each time the number of ranges will get divided, each time the size of the array will get divided by 2. So let me just show you the code for this particular problem now. So what I have done is I have initialized a vector v of size a, I have taken input in it, and I have calculated the prefix sums. So again, I have discussed it before also. How do I calculate the prefix sums? Prefix of I is equals to prefix of I minus 1 plus v of I minus 1. Now this I minus 1 is only because the difference in 0 and 1 based indexing. So now what I do is I just initialize my lower end and the higher end of the ranges as 1 to n. Now I just do simple binary search while low is less than high minus 1. I calculate the mid and I calculate the correct answer, right? So I just calculate the size of the range. So if I'm taking the left range, I do mid minus L plus 1. So it will be from L to mid, right? Now I just print the size and all the values from low to mid, because for the judge the query has to be of the form question mark and then all the values of the piles that I have to that I want my answer with, right? So once I perform this particular query, the judge will return me the sum of all the stones in the all the piles that I have mentioned, right? Once I get this value, I just check what is the required value, that what is the expected value. So I've written it REQ here. So this is the expected value. So this is the expected value which I was talking about, expected value, right? Now, if the correct value is greater than the expected value, then I'll search in this particular half, that is high becomes mid, and I search in the left range. Otherwise, I search in the right range and low becomes mid. Now, at the end, I'll be left with two values, low and high. So I just check whether I just check it for the low value, whether the expected value, whether the input value or the real value is greater than the expected value. I just print L, otherwise I print H. So like it's just the implementation of binary search. So in the way I implemented it, I had to check this particular value for the remaining two values. At the end, I'll have two remaining values as my answer. So I'll be having L and H. So in this particular case, I had to check for L separately. If the real value for L is greater than the expected value of L, the answer would be L, otherwise the answer would be H. So it's because of my implementation that I had to check L and H separately later. Otherwise, if you implement it in a different way, you might not have to check it later on, right? So it's just your implementation. You'll have to take care of all the values of the binary search, right? So let us move on to the next problem, that is problem F. So this particular problem is in this particular problem you have been given a n into m grid and the ball is initially at some position and we have been given a starting direction of the ball. So there are basically four directions that we have been and one of them will be given to us. So one of those is down right, down left, up right and up left. So these are the four directions that are possible. Now we have been given the initial position, we have been given the initial direction. So whenever a ball reaches this particular position, for example, if we are at this particular position, now the next step, the ball will go outside, right? So whenever such a state is received, the ball will bounce back, right? So for example, the ball bounce back from here. Now at this particular position again, the ball will go outside the board. So again from this particular position, the ball will bounce back and the ball can continue bouncing in this particular manner. So each of these bounces are counted and we have to tell whether the ball can receive the final index or not. So in this particular case, the final index was 2, 4. So whether we have to tell whether the ball can reach this particular index or not, and if it can reach, what are the number of bounces, right? So this is the whole question actually. So for example, this is the first test case and the answer is 3. You can see the ball started from here and it bounced from here, then from here, and then on the top, and then it's reached 2, 4. So this is the first test case and we were able to reach in 3 bounces. So how do we solve this problem? So we can solve this problem by treating this whole grid as a graph and by performing DFS or BFS anything on it. So from this particular index, we can reach this particular index and then this particular index. Even if we visit all the grids, even if we visit all the boxes, we know that we have to visit at most 5 into 10 to the power 4 boxes, right? So DFS is applicable to it, right? So in these questions specifically, you must, before thinking of a solution, you must check the constraints. So in this particular question, 5 into 10 to the power 4 would be the sum of all overall test cases of n into m, right? So if n into m is up to 5 into 10 to the power 4, then definitely we can visit all the boxes in the time limit, right? That is why we can apply DFS to it. Now the question is, how are we actually going to do it? So let me just show you. So for example, you have a grid like this. So this question is more of implementation rather than understanding. So, but still, I'm going to explain you. This, for example, we are starting from here. Now we have been given an initial direction, so we will move to this particular direction. Now again, we move to this particular direction. Again, we move to this particular direction. Now, if we go back, we will realize we have reached again a visited cell, right? But we have visited this cell while we were traveling in opposite direction. We have not visited it while we were traveling in same direction. So we will again move to the next cell, again move on to the next cell, right? So this will continue. But again, when we go back, we see that we have visited this cell while traveling in down left direction. That means we have to stop our DFS here. So like instead of just maintaining the visited of the positions x and y or the grid x and y, we also have to maintain the directions, right? This is very important thing that you need to take care of, along with maintaining the indexes or along with maintaining the visited of the indexes x and y. You also have to maintain it for the directions. Now how is this important? You will see, like for example, if we had the same grid and the initial starting position was this particular position. Now you move on to this particular direction. Now again you go back. You have already visited this particular box or this particular cell, but you have visited it while you were going down left. Now you are currently going up right. So the direction along with the ID of the cell or along with the index of the cell is important while determining this cell has been visited or not. Any cell can be visited in 4 possible directions, like this, like this, like this, or like this, right? So we have to maintain it differently for all the cells, right? So we have been given the initial directions, right? So whenever we encounter a position such that we go out of the cell, we can just simply reverse the directions. Now how do we reverse these directions? If we realize we have gone out of bounds for this particular wall, this particular or the x wall, so this particular wall or the y wall, right? So this is the column wall, right? So if we go out of bounds for the column wall, we reverse the column change, right? Otherwise, if we have gone out of bounds for the x wall or the row wall, we reverse the row change. So you will it's better to show you the code directly, because it's this question is more of implementation rather than understanding, as I've already told you. So I'm going to share with you the implementation. So what I've done is I've just taken these 3 variables as global variables n, m, and bounds, right? So I want you to read this very carefully. I just take the input n and m and I just initialize a boolean double dimensional vector, that is box. So I have named it box, but this is actually the visited array. So I have also initialized a vector of, so again this is a double dimensional vector of containing of sets that contains pair of int comma int. So for each I'll have a grid, like I'll have a n into m grid, and at each position I'll have a set. That set will store the directions I have visited. So why do I need a set? So I'm storing the directions like this, right? How do I store the directions? If I am moving, so dx and dy are going to be the change in my directions. So if I'm traveling downwards, so for example, if you have done grid DFS or grid VFS, you must be already aware of this technique where we take two variables dx and dy. So for example, if you are moving downwards, then in the next step our x is going to increase by 1, right? So I just take my dx to be 1. If I am moving upwards, my x is going to decrease by 1. So I just maintain my dx to be minus 1, right? If I am moving rightwards, my y is going to be increased by 1. That is why my dy is going to be 1. If I am going leftwards, my y is going to be decreased by 1. That is why I maintain my dy to be minus 1. So whenever I am at current position x and y, and I have the value of dx and dy, I can find my new position as x plus dx, comma y plus dy. Now dx and dy can have four possible combinations, that is minus 1, that is minus 1 plus 1, plus 1 minus 1, and plus 1 plus 1. So each of these combinations represent a particular direction, right? So minus 1 would be up, left. So this would be up, right. Plus 1 minus 1 would be down, left, and this would be down, right. So each of those combinations represent a direction. Now what I do in my directions vector, so my directions is a double dimensional vector like this. At each of those positions, what I'll have is I'll have a set containing these values. So if from starting from this cell I have already gone in minus 1 direction, this will be stored in my set here. If I have already gone in plus 1 minus 1 direction, this will be again stored in my this particular set. So whenever I am repeating a particular direction, I know that I have already visited this particular direction, right? So this is what I am going to store in my directions vector. So I just initialize some of my variables, that is the starting index and the ending index of x and y respectively. I just decrement all of them by 1, so as I can take 0 based indexing. Now I take my direction string, that is the initial direction. So I have already explained, if I am moving downwards, that means my dx has to be 1, otherwise my dx has to be minus 1. If I am moving rightwards, my dy has to be 1, otherwise my dy has to be minus 1. So if you have already done something like grid defense, I'm telling you again, if you have already done something like grid defense, then you must already be aware of this particular technique of maintaining dx and dy. So like I just pass some of my variables, like that is the starting index, the dx and dy, ending index, and the box and the directions vectors. So whenever I reach a particular position, I just mark it as visited, and whenever I realize that I have reached my final position, I just return. If I'm at the current index x and y, and I've already gone in this particular direction, so if the count is 1, that means I've already gone in this particular direction. I just return from here, because this means that this particular cell is already been visited while going in the particular direction of dx and dy. So this I can just return from here. Otherwise, I just insert into my directions vector, so that whenever I visit it later, I just know that I have already visited this particular cell in this particular direction. Now I calculate my new x and new y. So this would be dx, x plus dx and y plus dy. I just check whether it goes out of bounds or not, right? So I just need to check it. If it goes out of bounds, that means I will have to make a bounce. Now after making a bounce, how do I switch the values of dx and dy? Now if new x is greater than the number of rows, so that means if the new x direction or the new x is somewhere around here, right? If I somehow bounce out of the box in this particular direction, that means new x is here, or new x is less than 0, or new x is somewhere around here, right? That means I have to switch my x direction. So I just multiply my dx value with minus 1. So like this is why I have taken dx and dy like this now, because it is very easy to switch the directions here in this particular case. Similarly, if new y is greater than equal to m, that means if new y is here somewhere here or new y is on the left side, right? If it is less than 0, I just switch my y direction by multiplying it by -1. Now I again calculate my new x and new y, x plus dx and y plus dy is simple. I again check if it is not valid, then I just return. So what this means is, so for example, if this was my grid, if this is my starting position and I go in this particular direction, that is down right. So this position is not valid. So I switch my direction and I go up left. Right. This position is again not valid. Then I again switch my direction. So I again go down right. Then again go up left. I'll be stuck in a forever loop if this thing continue goes on. So I just check if the second value that I have obtained is again not valid. That means I just have to return it because I am stuck in a loop. Right. So again, I'll just show you the checker vector, a checking function. Here I just do simply whether x is less than 0 or x is greater than equal to m, or y is less than 0 or y is greater than equal to m. I just return false because these are all of the out of bounds values, otherwise return 1, right? So after all this is done, I again call my dfx function with the new values and this keeps on going on. At the end, if my current if my ending index are visited, that means I can just print the value of the number of bounces, otherwise I print -1. So this would be the solution for this particular problem. Now let us move on to the last problem for today's contest, and we are going to discuss the hard version because the easy and the hard versions are essentially the same ones. It's just that the hard version has bigger constraints. So in this particular problem, it says that we have been initially given an array containing just the number 1, right? So initially we just have one number. Now we can perform some operations, and in each of the operations, what we can do is we can select some subsequence of the array A and take all those elements and calculate their sum and add it to the end of the subsequence, right? And add it to the end of the array, right? So what we have to do is, we have been given some final array. We have to tell whether this particular array can be obtained with the initial array or not. So let me just explain you what the problem statement says first. So for example, we have been given the element first 1 here, right? Now I can only select this one. So the next element will have to be 1, obviously. Now I can select this one, or I can select both of them, right? I have to select some subsequence. I can select this one, or both of them. So if I select one of them, the third value will be 1. If I select both of them, the third value would be 2. Right. Now again, I have the choice of selecting some elements. I can select this particular element, or this particular element, or all of 3 of them, or any 2 of them. Right. Remember, it has to be a subsequence. I can select any of those values. So for example, if I select this particular 2 and this particular 1, then the next value would be 3. Right. Now again, I have to select some values. If I select all the values here, the next value would be 3, 4, 5, 6, 7. The next value would be 7. If I select these two values, the next value will be 10. So this is how the process keeps on going on. Now we have been given some final array A. You have to tell whether we can form this particular array or not. So this problem is not very difficult. It seems difficult, but it's fairly simple. Now let me just explain you some sample test cases. So for example, in this particular test case, so this is the third test case and the answer is yes for this particular test case. Let me just sort it first so that it is easier for us to see, right? I can, so initially only this element was there. I can take this element and make this particular element. So I have these two elements. I can take both of them, add them, and so 2 is formed. So I have these 3 elements. I can take this particular 2 and this particular 1 to form the sum 3. So I have these elements. Now I can take this particular 3 and this particular 2 to form the sum 5. So I have this particular element. Right, this is how I can form the whole array. Again, let us discuss one more test case, and for this particular test case, the answer is no. So the values are 1, 1, 2, 5 and 7. Again, I can form up to 2 as I've already seen, but using these 3 values, I cannot form the number 5 because 2 plus 3 plus 1, 4. So the maximum I can form is 4 and this value is 5. I cannot form this value. So my chain breaks here and the answer is no for this particular test case. Now, there is one very important observation to this particular series of operations that happens. So this is very interesting. The first two numbers will have to be 1 and 1, right? This is fixed. You cannot form any other sequence. So from these two, you can form 2, right? So 1 and 2 are possible for now. Using these two, I can form 2, right? So this is fixed for now. Now I can use all of them to form either 4, or I can use these two to form 3, right? Now I can use these two to form 7, these two to form 6, these two to form 5. Again, I can use these two to form 13, these two to form 12, these two to form 11, these two to form 10, and these two to form 9, and 7 and 1 to form 8. At each step, you will see by taking the last two elements, I am forming the maximum number, and I am able to form all the smaller numbers by using the remaining values. Right. I'll explain you once more the same thing. So in the initial two numbers are 1 and 1. Using these two, I can form 2. Using 2 and 1, I can form 3. Using 3 and 2, I can form 5. What about 4? I can still use 3 and 1 to form 4. Right. Using 5 and 4, I can form 9. What about the remaining values? 6, 7 and 8. Using 5 and 3, I can form 8. Using 5 and 2, I can form 7. And using 5 and 1, I can form 6. Right. So you see, using the last two values, I can form this particular value. And the remaining values will always be possible with the help of the remaining values, the remaining smaller values. Right. So this is exactly what we have to do. We just have to take care of the maximum value that we can form, and the remaining values will always be possible using the smaller values. Right. So let me just show you the code for this particular problem now. What I've done is I've just taken a vector v of size n, and I just take my input in it, and I just sort my vector so that like all of them are in sorted order. Now I just initialize the maximum value I can form, and that is equals to 1. I just check whether v of 0 is equals to 1. That means like this, the first number has to be 1. Otherwise, my answer cannot exist. So in this case, if it is not equal, I just return no. Otherwise, I just continue. Now for the remaining numbers, I just check if v of I is greater than the maximum value that I can form. Right? If v of I is greater than the maximum value I can form, I can just print no, and I can just return. Otherwise, I just add v of I to my maximum value, to my current maximum value. Why? Because if I can form this v of I, then if I can form this maximum value, then I'll be able to form all the other values using this maximum value and the other remaining smaller values. Right? So I just add it to my the maximum value, and I create the new maximum value. So at any point, if v of I is greater than the maximum value, the answer would be no. Otherwise, this loop will continue, and at the end, the answer would be yes. So this was it for today's contest, and we have discussed all the problems of today's contest that was rated for division 4. I hope you guys were able to understand the solution. So I know that this video is a bit long, and if you guys were able to understand the solution, then consider dropping a like on this video, and don't forget to subscribe to this channel. It's always free of cost, and if you don't find the videos interesting later, you can always unsubscribe. So till the next video drops, keep coding, stay safe, bye bye.